quantity is being sustained. What I'd like to do today is show you some of what we do to get to this point. So, what is the definition of sustainable yield? Sustainable yield is the level of commercial timber or product mix that can be maintained under a given management regime without reducing the long-term productive capacity of the forest. So the key concepts in here are the maintenance of the level of harvest over time of a timber product for products, given a certain forest management approach. So for any forest area there is no single measure of sustainable yield. So sustained yield can vary with different forest management approaches. So if you just want to produce pulpwood, you would manage the forest by harvesting at a younger age for pulpwood. But if you want to produce sawlog, you have to grow the trees on for a longer time to produce larger trees that are suitable for sawlog. These two management strategies have different sustained yields. Then there is another part to this definition which is about maintaining the forest capacity in a good condition so that there's something left for future generations. And this is the idea that we have to maintain the long-term productive capacity of the forest. So, Forestry of Tasmania's overarching goal is a sustainable management of state forests of Tasmania. Sustainable yield of wood products is just one part of what we, Forestry of Tasmania, manage the forest for. Sustainable forest management is concerned with riverbank forests being sustainably managed with a full range of benefits, environmental, economic and social, for current and future generations, providing a balanced return for more forest uses. So there's a balance there between wood production and multiple forest values in the state forest. And the sustainable yield of wood products from our forest estate is what we're focused on today. In my next few slides, my aim is to help you put FT's wood production forest estate in context with the rest of Tasmania. So of the 6.8 million hectares that makes up Tasmania, 39% is privately owned, which is that yellowish area, mainly through the midlands. Another 39% is public land, and that's the blue area, that's either national parks or World Heritage areas. The remaining 22%, or just over 1/5, of Tasmania's state forest, managed by FT. And this is the green bit, and it equals about 1.5 million hectares. So breaking down the green area on the previous slide, we can see this broken up into 3 areas: formal and informal reserves, outside wood production areas, and wood production areas. So about 1/3 of state forest is in formal and informal reserves. And this is to protect multiple forest values, and these areas are not used to produce wood. Just under 1/5 of state forest has not been identified specifically for either wood production or reservation. And wood production areas make up 46% of state forest, and they're areas specifically identified for wood production. Our wood production forest estate lies within that 46%. And this area is predominantly native eucalypt and plantation, consisting of hardwood plantation, softwood plantation and special timbers. The eucalypt native forests and hardwood plantations make up almost 90% of this area, and is an example of a forest estate model from which we can calculate sustained yield. It's important to remember though that this area represents strategic areas, and areas identified at a strategic level, and represent the gross areas. So what actually gets harvested after operational planning is often much less to protect non-wood values within the wood production area. To date, forest management of our wood production forest estate has been focused on ensuring the sustained level of a yield of eucalypt high quality sawlog. This is the product of interest to us when we're calculating sustained yield. And so a saw log is what its name suggests. It's a log that gets sawn up into sawn timber for furniture and framing. And it's usually the bottom part of the tree, and it's got to be straight, free of knots, and at least 30 centimetres wide at the smallest end, so that you're able to saw it up. And the rest of the tree is segregated into other logs for other end uses. So saw logs are the important product that we're focused on generating from our wood production forest estate. And the Forestry Act provides clear guidance for the sustained yield of high quality saw log. And Section 22A requires Forestry Tasmania to make available for the veneer and sawmilling industries each year a minimum of 300,000 cubic metres of eucalypt high quality saw logs. So what do we do in the forest to produce the wood? There are a range of silvicultural systems in the forest used to produce the wood. One of the most common is partial harvesting in dry forests, and this accounts for about half of the area harvested each year in state forests. And the concept of partial harvesting is that in the forest some trees are removed and others are left to grow on evenly spaced, and usually you can come back to the same patch of forest one or more times in a 90-year period. For wet forests, however, clearfell, burn and sow is currently the most effective and practical system. And notionally, the rotation age is about 90 years, and that's to allow the tree to get large enough to produce saw logs. However, thinning of suitable regrowth can accelerate saw log growth and reduce the notational rotation age to about 65 years. Aggregated retention is another system where patches of unharvested forest are left within the harvest area, ensuring that the area harvested is generally within one tree length of the forest edge. And last but not least, plantations are a relatively small area of state forest, but actually they're a very important source of our future wood supply, especially given increased levels of native forest reservation. And normally we prune plantations up to 6.5 metres when they're quite young, so that they grow on and they have a nice straight stem that we can produce saw logs from 25 years later. So as a result of these silvicultural systems, across the landscape we've got areas of coop native forests and plantations, some thinned, growing to produce the future wood supply by being harvested at different times. And coops, I just wanted to define coops. Some of you may not have heard that before, but they're areas that are managed as a discrete unit of area, usually between 10 and 60 hectares in size, and they usually contain the same type of forest, and all of a coop will be harvested and regrown in the same period of time. And we can see a few coops here. There's one, and down the bottom here we can see a plantation coop, and we can see that all the trees are generally about the same size. So in order to calculate sustained yield, we need to first predict a pattern of harvesting over time, and this can be represented in a forest estate model like this one. And this shows coops as polygons, and the polygons you see here, polygon is just a fancy word for shapes, by the way, and as opposed to road lines. These polygons are coloured in according to what year we think they're going to be harvested. But in order to do that, we need to know a lot about the forest to be able to predict what's going to happen in the future. So how do we work out what type of forest is there, how much wood is in the forest, and which areas we can set aside for protection and which areas we can set aside for production? We have a planning system that helps us to do that, and the first thing we need to know is what type of forest is there. So the thin lines here, you can just see them, represent define polygons of different forest areas. So types of forest such as tall mature forest, young regrowth forest, mixed forest and rainforest. And these areas of forest are usually mapped using aerial photographs. We overlap these aerial photographs and we use a stereoscope so that we can see the forest in 3D, and using this we can delineate like and unlike forest types, like this. And these areas of different forests are sampled by measuring trees in plots in the different forests. In these plots we measure things such as tree numbers, species and size. And normally we use a GPS to locate the plot, and we use a vertex to measure angles and distances so we can get the tree height. We use a D-tape to measure the tree diameters, and a bark gauge to measure how thick the bark is. So we end up with these measurements from which we can work out the volume of saw log and other logs in each forest type. And these measurements are then fed into growth models to grow the tree measurements for the forest into the future. So we worked out what type of forest is there and how much wood is in it. So how do we work out which areas have been put aside for protection and which areas we think we can harvest? Management zones delineate forests for wood production, and forests manage to protect other values. These other values include streamside reserves, eagle nest exclusion reserves and so on. And we don't harvest these areas. The brighter green polygons here represent coops. These are the areas that make up the 46% that we saw in that pie chart earlier. And we think we might be able to harvest these coops. So by intersecting these coops and the forest types and their wood volumes, we can calculate the amount of saw log and other logs that's standing on each coop, and also what will be there as it grows into the future. So these are the basic components of FT's forest estate. We have an area of forests of eucalypt and arbor plantations, which are defined using GIS, and we've talked about that before. And attached to these areas are the volumes of saw logs and other logs for each coop now and grown on into the future. These are derived from the plots we measured earlier, and we call them yield tables. Finally, the forest management strategy is input, usually as a set of policies, goals and silvicultural systems. And all this takes place on a computer where we have a forest estate model which we input the area volumes and management strategy. Using specialist software, we use linear programming optimization. And this is a mathematical method used in this case to suggest coops for harvest given certain objectives and constraints. And our model is run for a long time, usually about 90 years into the future. So here's a nice picture of people and computers working out how to model the forest estate and doing it. And we're going to do that right now. So this is a real live example of forest estate model, and it's in a program called Woodstock. And the polygons you see here are an example of a part of our forest estate, polygons representing the coops. And what I'd like to do is show you 3 scenarios where we ask the linear programmer to suggest a sequence of coops to harvest that maximises the economic return. So the first run we're going to do contains few rules, and we call this an unconstrained run. And what we can see here is that there are 3 graphs, and the first one shows the wood flow of saw log and other logs by year on the x-axis in metres cubed. And the graph below that we can see this is the area cut every year to produce the wood flow above it. And over on the far right we can see a graph of the volume that is remaining standing in the forest over time. So one constraint in all these sustained yield calculations that we're doing here is that the amount of standing volume must be the same at the end of the 90-year run as at the start. And if we can see it here, so this volume is about the same or greater than the standing volume where it starts. The problem with this unconstrained scenario is that it's way too spiky in terms of the area cut. We can't manage a forest like that. We can't manage our forest contractors like that, our harvesting contractors. So in the next scenario, I'm going to show you a scenario where we smooth the area cut each year. So what we can see here is it's a much more realistic pattern of harvesting. So the volume, the area cuts remaining about the same from year to year. But what we can see though is that we can see in this top graph the sawlog volumes are still rather up and down, and that's not very practical either, because sawmillers need to have an even supply of wood from year to year. So I'm going to show you one more scenario where I've made a rule that smooths out our sawlog volumes. So what we can see here is it's a much more realistic pattern of harvesting. We can see that the sawlog is being sustained over time for a period of 90 years. And this is much more realistic in terms of what we can start building more rules into. And there's other rules that you can build into further scenarios. These are just 3 scenarios. There's things like making sure that the right type of forest is being harvested. So we've got a policy where 80% of the annual old growth area that is cut each year must be cut using a partial harvesting system. And that's an example of a rule that we could easily build into a next scenario to ensure that the wood flow schedule becomes even more realistic. And what we can also see is that there's as much wood standing up at 90 years as there is at the start of the model. So once we've run a bunch of scenarios, we communicate these results internally and externally. And a really important part of calculating sustained yield, and it's one of our bread and butter jobs, is that we conduct 5 yearly reviews of our forest estate modelling, which are linked to the RFA, and these include independent external review. So what does the output from all this look like? Well, here's a result of a 5 yearly RFA wood review, and it's a sustainable wood supply graph. And what this graph demonstrates is a sustainable wood supply from state forests over 90 years. And that was calculated for the 2007 5 yearly RFA wood review. And it shows a sustainable yield of high quality sawlog of 300,000 cubic metres per year, in line with the Forestry Act requirement. And you might note that the wood supply is made up of both eucalypt native forest and the plantation, which represents our whole forest estate. So what we can see here is that over 90 years in the native forest, different types of forests are being harvested using different harvesting systems. So we've got the yellow here represents sawlog arising from thinned regrowth forest, and the green shades represent sawlog coming from regrowth forest. The blue represents partial harvesting of mature and regrowth forest, and the dark blue represents mature forest sawlog. So although there's a lot of future sawlog coming from regrowth forests, it doesn't necessarily mean that all the older forest is being cut down. Older forest exists outside the area of coops used for wood production. That is the other half of state forest, and also other public land that is reserved. And not only that, but not all of a coop is harvested. So within our current coops, there will also be older forests still standing for the future. To further demonstrate this, I'd like to show you some of our measures of sustainability. This chart shows the maturity of eucalypt forest now and 90 years into the future. And we can see we've got the standing area in hectares on the y-axis and the type of forest along the x, generally increasing in age. And what we could see from this is that the mature, which is predominantly outside wood production, is about the same in 90 years as it is now. And this can be said for the area of plantations as well. Whereas the regrowth forest, the stuff in the middle here, changes its composition as a result of harvest and growth over time. This chart shows the standing volume of eucalypt forest now and 90 years into the future. What we can see here is that the amount of wood in the forest increases, and it also shows that over a 90-year period we harvest less than the growth of the forest. So we're not reducing the long-term productive capacity of the forests, and you might remember that that is one of the core to the definition of sustainable yield. What this also means is that in 90 years from now there will be management options available to future generations which include continuing wood production at the same level as we do now. And finally, this is another example of where we might end up after calculating sustainable yield for a forest estate using a forest estate model. So there's more information on the Forestry tab's website, and if you're really interested in exploring the calculation of sustained yield in much more detail than I've presented today, there's an article titled Calculating the Sustainable Yield of Tasmania State Forests, and that's in Tas Forests, Volume 11, from 1999. Thank you for your time.